So, we can define different random variable on a same sample space. Let us discuss one example. Let the random experiment, let us consider random experiment, tossing a coin 2 times. So, tossing a coin actually twice, basically you are same coin, and here we did not mention about what is the probability head of the coin. So, here we assume that probability of head may be probability of head is nothing but half. So, basically we assume it is a unbiased coin, or we say fair coin. Now, what will be the sample space? In this case, sample space S is equal to, so we are tossing a coin 2 times. So, that means 2 observation we will get for every run of this experiment, either it will be both head or one head one tail, or maybe one tail one head, and both may be tail. So, this is head head, it may be head tail, it may be tail head or tail tail. So, this is this sample space. So, all possible outcomes. In which run which outcome it will appear, we do not know. So, now let us define a random variable x. So, it will be a measurable function from S to R, defined by x of any point S is equal to number of heads observed or obtained. So, number of head obtained. So, basically whenever tossing a coin, we obtain some head, two heads, maybe one heads. So, that means x of head what will be this value, because number of heads is 2. So, that is why it will be 2. X of head tail, this will be nothing but 1, because only one head. X of tail head, this is will be equal 1, and x of tail this will be is equal to 0. There is number of heads is 0 here, because no heads. Another random variable let us define. We can define another random variable y S to R, another random variable. So, this is defined by y of S, this is equal to number of tails obtained. So, in that case, what will be y of head? So, this will be is equal to 0, because number of tails here we are talking about. What is the number of tail? Because 2 heads observed, so obtained. So, then number of tail will be 0. Number of y of head tail, this will be 1, y of tail head, this will be 1, and y of tail this will be is equal to 0. Sorry, number of what head tail, it is number of tail is 1, that is why 1. Number of tail head, it is number of tail is 1, that is why 1. Number of tail it is number of tail obtained. So, this is actually 2. So, this is actually opposite of x, actually number of tail we have to consider here, this random variable. So, 2 random variable we consider. Now, we define bivariate random variable. So, bivariate random variable, let us see that what is the definition. Let S be a sample space of a random experiment, like here it is a S be a sample space. So, let us consider this example, and so S is the sample space. So, here suppose this is head. Now, this is suppose this is head tail, this is tail head, this is tail. So, this is the whole sample space S. Now, by random variable x, what is the, this is suppose, so this is suppose 0, this is 1, this is 2, this is 3, this is -1, -2, -3, here this is 0, 1, this is 2, this is 3, like this. Now, x of head is nothing but 2. So, this is okay. I just mapping x by the x axis, and this is y axis. So, x of head is equal to 2. So, this is 2, this is x of head. Now x of h of ht, x of ht will be 1. So, this will be coming to 1, this is also coming to 1. So, this is x of ht, th, now it is x of ht, x of ht, this is x of th, and then tt it is going to 0. So, it is x of tt. Now, what about the random variable y? So, random variable y, x of tt is y of tt is 2. So, this is going to here, this is y of tt, and both are going to 1 here, this y axis, this is 1, this is also 1. So, we will represent y of th, now this is y of th, and this is y of ht, and then this value it is going to 0, y of hh will be going to 0. So, this is nothing but y of hh. So, this is nothing but y of hh. So, this is little complicated in the graph, but we have understood that. Now, why we are drawing this graph? Because in this definition, let x be a sample space of an experiment and x and y be two random variables, then the pair xy is called the bivariate random variable, two dimensional random variable. If each of x and y associate a real number, then every element of S it will be associate x and y if each of x y associates a real number with every element of S. So, now we define this random variable. So, usually x is any random variable is a function from S to R. Now, this is a vector we consider, this is denoted by x, y, this is a function from S to R2. So, this is a bivariate defined, a bivariate random variable is a measurable function, measurable function, this x y from S to R2 defined by x of y S, this is nothing but, so it is a function from S to R2. So, it will every S it will map to R2, what will be the value? This is in xs ys, xs ys. So, xx is a real number, ys is a real number. So, this is a vector in R2, this is nothing but this R2. So, this is called a bivariate random variable. Now, bivariate random variable, if the random variable suppose both are discrete random variable, then this random variable xy it is called the discrete bivariate random variable. If x and y both are continuous random variable, then this xy this random variable it is called a bivariate continuous random variable. If one of them are discrete and one of them are continuous, then it is called a mixed bivariate random variable. So, now if we graphically represent this, see that what is the range of x. So, range of x is the nothing but range of this random variable x. So, range of x is nothing but 0, 1, 2, and what is the range of y? Range of y is nothing but 0, 1, 2. So, if you consider in the cross product, that means if you consider Rx cross R2, Ry, Rx cross range, this is nothing but it contain 3 square element, nothing but 9 elements it will consider. So, basically this is suppose it is 0, 0, 1 vector. So, I am so for simplicity let us denote the as a vector as a this first bracket. This is to understand it is we understand that this is a vector, but actually we represent actual if we properly represent that it is a we usually represent by third bracket and this transpose dash, this is nothing but the row column vector as a column. So, now this is 0, 0, 0, 1 transpose, then 0, 2 transpose, and then 1, 0, 1, 1 and 1, 2, and then 2, 0, 2, 1 and 2, 2. So, this is the range of this random variable, sorry, range, not it is nothing but Rx minus Rx cross Ry. Now, let us again find out what is the under this xy. So, this is the sample space. So, this is head head, then tail head, head tail, then tail head, and then tail tail. So, now this is 1, this is 2, this is 3, minus 1, minus 2, like this, 1, 2, 3. So, now under this random variable xy, this function, it is from S to R2. So, how it is? So, what is the xy of head head? This is defined by x of head, y of head. So, this the x of head is nothing but 2, y of head is equal to 0, because x of head is number of head. So, sorry, it is 1 minute, just let us write down again. Let us find out what is x y of head head, one of the element S head head. So, this is nothing but, by definition, this is nothing but x of head head and y of head head. So, x of head head is nothing but number of heads of 10. So, this is 2 and x of y of head head is 0. So, this is nothing but 2 0. So, basically under this, so this is coming to 2 0. So, this point. So, this is mapping to this point, this is nothing but x y of head head. Now, what is the value of, suppose, x y of head tail? X y of head tail, this is nothing but x of head tail, y of head tail. So, x of head tail is also 1, this is also 1. Similarly, what will be x y of tail head? This point, this is x of tail head, y of tail head, this is nothing but again 1 1. Now, if we consider the only point tail tail, so this is x of tail tail, y of tail tail, this is x of tail tail is 0 and y of tail tail is 2. So, 0 2. So, now we graphically, if we represent it, x y of head head, x y of tail tail, both are going to the same point 1 1. So, here this is the point 1 1, this is the point 1 1. So, both head and tail both are actually going the same location. So, this is also and this is also, this is x y of head tail and this is x y of tail head. Now, what will be the x y of tail tail? So, this function, this value, this is nothing but 0 2. So, 0 2 is 0 2 is here, 0 2 is here. So, this is going to this value. So, this is x y of tail tail. So, then what we found? What is the range of this random variable, bivariate random variable? The range of this bivariate random variable we denote by Rxy. Rxy will be what are the point it contains? See that 0 2 it is pointed. So, this point 0 2, this is the value 0 2 and then 1 1 also, and also another point is 2 0. So, 2 0 2 0. However, you can see that Rx cross Ry, this contain many more points, only 3 points it contains, like 0 2, 2 0 and 2 2, these 3 points contained in the range of the bivariate random variable. So, this Rxy may not be same as Rx cross Ry, but it will be always subset of Rx cross Ry, range of x cross Ry. So, it is actually, it may be sometimes is equal to, exactly equal to, but most of the time. So, we can see this example at least, that it will be subset of Rx, range of this bivariate random variable Rxy will be subset of Rx cross Ry. So, hope you have understood that the definition of the bivariate random variable. Now, this example we have already discussed. This example the example is that consider an experiment of tossing a fair coin twice. Let xy be a random variable, bivariate random variable, where x is the number of heads that occurs in 2 tosses and y is the number of tails that occurs in the 2 tosses. What is the range of range Rx of x? Always we have already discussed, this is nothing but 0, 1, 2, and what is the range of ROI? ROI also nothing but 0, 1, 2, we have already discussed, and find and sketch the range of RXY. So, range of RXY is nothing but we have found that is 0, 2, 0, 2 and 1, 1 and 2, 0, 2, 0. So, it is all points are in R2. Now, the question is that what is probability of x equal to 2, y is equal to 0. So, this comma, this notation we have already discussed, but we will discuss again what does it mean. So, let us find out the first find probability of x equal to 2, y is equal to 0. So, we have already discussed the notation x equal to 2. X is equal to 2 we know this notation is equal to all s in the sample space S such that xs is equal to 2, and y also, y another question is that this y is equal to 0. So, y is equal to 0 also we know. So, but let us find out what are those value. So, let us remember that the sample space contain this 4 point S is equal to head head, head tail, tail head and tail tail, and all S corresponding to S such that xs is equal to 2. So, xs is equal to 2 means number of head will be 2. So, this is nothing but this point is nothing but this head head. Now, the next is what is y is equal to 0, that also we know this is all S corresponding to S such that xs is equal to 0. So, that means sorry ys is equal to 0. So, here it is this is the random variable is y. So, we have to be careful that ys is equal to 0. So, then for which point y is defined by the number of tails obtained. So, a number of tail it will be 0, then that means this is nothing but the point head head. So, this is nothing but again head and head. Okay. So, now if you want to define this, what is this? X is equal to 2 comma y is equal to 0. So, this is nothing but the event corresponding to, because we already know what is the event. This is a subset of S, this is also a subset of S. So, we know already it will be a subset of S, but what is this notation? This notation is corresponding to like x equal to 2, it is a event in S, intersection y is equal to 0, it is also event in S. So, comma means it is a intersection of two events. So, then this is nothing but we have found that this is nothing but this is head and this is intersection with again head and head. So, this is nothing but head and head. So, now we can easily find out that what will be the probability x equal to 2, y is equal to 0. This probability is nothing but there are 4 equally likely points, because H we consider probability of head is half air. So, it is a unbiased coin we are we have assumed. So, this is nothing but 1 out of 4, this is 1 by 4. So, in general how we define this? So, we can talk about like x is equal to some x, y is equal to some value real number y, x is the random variable, y is equal to, or we can talk about x less than equal to x, y is equal to y. We can talk about anything less than equal to x, y less than equal to y, like this. How it is defined? So, actually we have, suppose if you want to define it, we can define this is by a event Ax such that this is nothing but x is equal to x. How it is defined? All S belongs to S such that x of S is equal to x, and now B y is the another event, it is defined by y is equal to y, which is nothing but S belongs to S such that y of S is equal to small y, y is in small y is a real number. So, then Bx, Ax and Bx both are subset of S. So, it is a event. So, this is nothing but the event Ax intersection By. So, if you for simplicity, for understanding only, we use the notation, or you can directly write that like this. So, this is nothing but the event corresponding to S equal to x, because we have already for enumerated random variable we have already discussed this is a event, intersection y is equal to y, it is another event. Similarly, here also x less than equal to x, it is a event, intersection y is equal to y, it is another event. Similarly, here also x less than equal to x event, intersection y less than equal to y. So, this is, so then we can talk about this probability means we are talking about the probability of this event. this probability of this event, we are talking about probability of this event. Probability of this event is nothing but we are talking about probability of this event. So, this is just a notation, you have to understand this notation. So, if you have followed this notation, then we can do some other examples also, how to find the probability x equal to 0, y is equal to 2. So, x equal to 0, probability of x is equal to 0, y is equal to 2, it is nothing but probability that x is equal to 0 intersection y is equal to 2. So, this is also, so x equal to 0, what is the event? X is equal to 0 is nothing but all s belongs to the sample space S such that x s is equal to 0. X s is equal to 0. All s belongs to the sample space such that x is equal to 0. So, x is the number of head. So, what is the sample space here? Sample space S already we know, this is nothing but head head, head tail, tail head and tail tail. So, then what are the point in S such that x is equal to 0? This is nothing but tail tail, because number of head will be 0, number of head is, this is nothing but tail tail. So, now how to find y is equal to 2? So, it is nothing but all S belongs to S such that y of S will be is equal to 2. So, ys is defined by number of tails. So, number of tails is nothing but 2 is again tt is number of tails. So, this is tt. So, then x is equal to 0 intersection y is equal to 2, this is nothing but, so both are same actually in this case, in this example. So, in previous also case also same, hence it is out of 4 1, here also this x is equal to 0, y is equal to 2, this is nothing but this probability of this event. This event is nothing but it is by the classical approach equivalently 4 points, out of that 1 points 1 by 4. So, now next example is that find probability of x equal to 1 and y is equal to 1. So, x equal to 1, y is equal to 1, how to find that? So, probability that x equal to 1 comma y is equal to 1. So, this is nothing but probability of probability that x is equal to 1 intersection y is equal to 1. We have to find the corresponding events and then we can take the intersection and find out the probability. So, let us write down what is S here. S is the head head, head tail, tail head and tail tail. So, what is x is equal to 1? X is equal to 1 is all S belongs to S such that x s is equal to 1. So, that means number of head will be 1. So, number of head is all these head tail and tail head. Similarly, if you consider y is equal to 1, here it is nothing but all S belongs to S such that y s is equal to 1. In that case also, because number of tail 1, head tail and tail head. Actually, all the example this is coming same. So, that is why there is no intersection, actually is nothing but same head tail tail head. Now, what will be the probability? Probability x is equal to 1, y is equal to 1, because 2 out of 4 points equally likely. So, 2 by 4, this is nothing but 1 by 2. So, it seems like always it is same. So, let us consider suppose we are to find x equal to 1, y is equal to 0. So, this probability if you want to find. So, this probability if you want to find, then s equal to 1 the corresponding to this event. So, this is nothing but x is equal to 1 intersection y is equal to 0. So, then x is equal to 1 corresponding to head tail and tail head. Now, what is y is equal to 0? So, y is equal to 0 is nothing but corresponding to the number of tail will be is 0. So, this is intersection of head head. So, here you see that all are same, all not same. So, that is why y is equal to 0, okay, y equal to 0 we can find, you can see that this is S, all S such that y is equal to 0. So, here a number of y is given the number of tails. So, y is equal to 0 means it is number of tails. So, head head. So, this is correct. So, now, but this intersection is phi. So, it is null set. Hence, probability that S equal to 1, y is equal to 0 will be probability of the null set. It is not possible. This is 0. So, you are tossing 2 coins. You get 1 head. Again, you get 0 head. So, both the possibility, intersection means both event happened. So, both cannot be possible, because if it is one head occur, then it cannot be one head and one tail occur. So, it cannot be both head, then number of tail will be 0. So, that is why this is not possible, this probability will be 0. So, this is one example. Now, we will introduce the joint distribution function. So, joint distribution function. So, now you can we just remember the what will be the univariate, for univariate cases what is the cumulative distribution function. As we have discussed, we have already defined cumulative distribution function for univariate random variable. So, let x be a random variable. So, let us, so it is a function from, so the cumulative distribution function, recall that the cumulative distribution function of univariate random variable of x is defined as f of x nothing but probably that x less than equal to x for x belongs to real number. So, now we have now bivariate random variable. So, how we define this bivariate random variable? The joint cumulative distribution function so joint C.D.F, we say that joint C.D.F. So, we say joint C.D.F of a bivariate random variable. So, of a random variable. So, usually we write xy like this or third bracket xy, but for simplicity sometime we will write first bracket xy like that. Bivariate random variable xy is defined by, so see that it is only one variable, here two variable f of xy small x small y, both are real number. This is nothing but probability that x less than equal to x comma y less than equal to y. What is comma? We have already discussed. For all x y is a vector in a R2, or you can say that x belongs to R and y belongs to R. Then x y, this is in a order pair, it is x y is in R2. So, now what is this? X less than equal to x, y less than equal to y. So, x less than equal to x, we know it is a event. So, this is nothing but all s belongs to s such that sample space, because x and y are defined same sample space, is a random variable, or x of s less than equal to small x, and this is suppose we denote by a event ax, because it is depend upon the function x, and y less than equal to y, again it is a subset of s, it is a event, all s belongs to s such that y of s less than equal to small y. Small y. So, this is nothing but we let us denote by by, it is a subset of s, this is a subset of s. So, it is a event. So, we assume that because x is a random variable, that means it is a measurable function. So, it will be in the sigma field, and there similarly by also subset of s, it will be in the sigma field, because y also a measurable function. Now, this is also event, this is also subset of s. So, then ax intersection by, because it is in the sigma field. So, x intersection by will be inside the sigma field. So, this probability is nothing but probability that x less than equal to x intersection y less than equal to y, which is nothing but probability that ax intersection by for all x and y. So, this is the definition of the cumulative distribution function. So, let us see that a joint cumulative distribution function or joint C.D.F of x and y denoted by fxy of xy is the function defined by fxy of xy is nothing but probability of x less than equal to x, y less than equal to y. Now, the event x less than equal to x, y less than equal to y is equivalent to the event a. So, I just denoted because it is dependent upon x and y. So, x intersection by, where a and b are events in S defined by all S belongs to S such that x of xi actually zeta it is notation less than equal to x. B is all S zeta belongs to S, y of zeta less than equal to y. We have already defined this. So, this is Ax, this is By. Then probability of, what is probability of Ax actually? So, probability of Ax is nothing but probability of probability of x less than equal to x. So, this notation we have already used here. This is nothing but the cumulative distribution function of x. So, similarly probability of By, it is denoted by probability of y less than equal to y. This is nothing but cumulative distribution function of y. So, whenever we are talking about a bivariate random variable, and we know we suppose we denote fxy of x comma y, it is a bivariate random variable fxy of x comma y, bivariate cumulative joint cumulative distribution function of the bivariate random variable. Then any the cumulative distribution function of the subset of the random variable, subset here only x and y here. So, cumulative distribution function of x and cumulative distribution function of y, we say it is a marginal distribution. It is just a name, it is a some kind, it is a some usually call that it is called the marginal distribution function. So, P of A is fxx, P of B is fyy, fxy of xy is nothing but ax intersection by. So, this should be, it depend upon y. So, that is why if for particular values of xy, if a, b are independent events, then s, then this will be happen. So, now we will discuss on important properties. So, suppose when we say two events are independent, suppose for any real number x and y belongs to real number. So, basically we are considering xy belongs to R2, x is a subset of S and by is also a subset of S, and these are all in the sigma field. And then we are talking about that x intersection by is the joint distribution function. It is nothing but probability that x less than equal to x comma y less than equal to y, which is nothing but probability that x less than equal to x intersection y less than equal to y. We denoted this event by ax intersection by. Now, x and by for fixing x and y, x is a event, bx is a event. So, you know that a and b will be independent if their product is nothing but, sorry, their intersection, probability of the intersection is nothing but probability of x into probability of by. So, now if it is true for all xy, if for all xy belongs to R2, that means fxy xy, this is nothing but probability of x intersection by, which is probability of x into probability of by. What is probability of x? Probability of x less than equal to x. What is probability of by? Y less than equal to y. This is nothing but fxx and this is nothing but fyy for all xy belongs to R2. So, if this happen, then this bivariate random variable, then x and y is called is independent, sorry, then x and y are independent random variables. So, this is the definition. So, we know that what is the definition of two random variable a and b are two events are a and b are independent. So, that is definition is a intersection b will be probability of a into probability of b, but here x and y also involved. So, for a particular x and y it may be true, but then we cannot say that x and y, this capital and capital random variable independent. If this is true for all xy belongs to R2 or all xy in R for any real number x and any real number y, if this is true, then these two random variable x, y will be called independent random variables. So, that is why this is the definition. So, if in particular x and y we are independent events, then this is true, but when we will say independent events, then whenever it is true for all x, y, for all x, y, if it is true, so then we say that it is a independent random variable. So, that we will discuss in the next part some of the concept of independence of two random variable. Also we need to discuss what are the properties of the bivariate random variable. So, univariate random variable, what is the properties of the joint distribution function, cumulative distribution function. So, next we want to discuss what will be the properties of x, y. So, like we have already discussed what are the properties of fx's, like univariate random variable, marginal distribution function, we know some of the properties. Now, we want to know what are the properties of the cumulative distribution function. Also, we will discuss some of the numerical examples of bivariate cumulative distribution function, joint cumulative distribution function of bivariate random variable x and x, y.